Today we will see first the differences between mass and weight, and then we'll go for Newton's third law of motion. Okay.
Yes, ma'am.
So you have any idea about mass and weight?
Ma'am, no,
Yes. No idea.
no, no.
Okay. So what is mass basically? It is the amount of matter contained in a body. Amount of matter contained in a body. Like for suppose if you take our body itself, like if you take a human body, our human body is made up of blood, muscles, organs, bones, everything, right? So if you take the amount of the entire content that is in our body, that is called mass. Maybe 50 kg, 40 kg, that is your mass. Okay. But what is weight? Weight is a kind of force. It's a kind of force with which a body is pulled downwards. A body is pulled towards the earth. What does it mean basically is, Gautam, like when you take an object, okay, which is having mass m, it will be pulled towards the center of the earth, right? due
Yes,
to
ma'am.
due to gravitational force, the body will be pulled towards the center of the earth, right? So how much force is acting on this body to make it pull towards the center of the earth? That force is nothing but weight.
Yes, ma'am.
In a simple way, it's nothing but force of gravity. Weight is nothing but simply force of gravity. With how much force the body is pulled towards the earth. Maybe with the 2 newtons it is pulled towards the earth, or 3 newtons it is pulled towards the earth. That is your what? Weight. You know gravitational force, right? Earth will be attracting all the objects on it, isn't it?
Yes, ma'am.
With how much force it is attracting, that is nothing but weight. Earth is attracting the objects, but with how much force? That force is nothing but weight. So weight is basically a kind of force. Okay.
Yes, ma'am.
Now, and what is the formula for this weight? It's nothing but m into g. Generally, what is the formula for force? Yesterday I told you in Newton's second law. Force formula is what? F is equals to m into a, mass into acceleration. Okay.
Yes,
So
ma'am.
weight formula is also similar to force. Why? Because weight is also a kind of force. In the place of F, we'll take W symbol. M is same mass of the body, but here acceleration is because of the earth attraction, right? So
Yes, ma'am.
we take, instead of A, we take G. And what is this G? It is acceleration due to gravity.
Yes, ma'am.
Acceleration due to gravity. That means because of the earth's attractive force, the body is possessing acceleration. Clear?
Yes, ma'am.
ఎక్స్టర్నల్ ఫోర్స్ అప్లై చేయడం వల్ల యాక్సిలరేషన్ వస్తే అది ఏ. అర్త్ అట్రాక్ట్ చేయడం వల్ల బాడీ మూవ్ అయితే అప్పుడు యాక్సిలరేషన్ వచ్చి జీ. క్లియర్ విత్ దిస్ పాయింట్?
Yes, ma'am.
ఓకే. సో దిస్ ఈస్ ద ఫార్ములా ఫర్ వెయిట్, ఎమ్ ఇంటూ జీ. నౌ సెకండ్ థింగ్, మాస్ ఈస్ స్కేలర్ ఆర్ వెక్టర్?
Scalar.
Yeah, mass is a scalar quantity. And what about weight? Weight is a kind of force, and force is vector quantity. If you take g, if you take weight formula, that is m into g. What is g? Direction towards the earth, right? The body
Yes,
is
ma'am.
pulled towards the earth. That means there is a direction. So weight is what? Weight is a vector quantity. Now when you take mass, wherever you go, it remains constant. That means, for suppose right now my weight is 65 kgs. Now if I go to moon planet also, my weight will be, I mean my mass will be 65 kg. If I go to Jupiter planet also, my mass will be 65 kg. My mass doesn't change. Mass will remain constant. But when you take weight, no, it don't remain constant. When we are on earth, some value. When we are on moon, some value. When we are on Venus, some value. So when we change the place, the weight value changes. Okay. So it do not remain constant.
Ma'am, because here acceleration due to gravity is different.
Exactly. Acceleration due to gravity differs here. So earth pulling will be different, moon pulling will be different, different objects exert different amount of force, right? So there will
Yes.
be a change in g value, and because of that there will be change in weight also. Okay.
Yes, ma'am.
Now, what are the units of mass? If you take CGS system, gram. If you take MKS and SI system, kilogram. And 1 kilogram is equals to how many grams? 10 to the
House.
power of 3 grams, 1000 grams. Okay. Now, what are the units of weight? Weight is a kind of force, right? So you can take newtons and you can take dynes. Okay. But here what we do is we take gravitational units also. Gravitational units. Why are we taking gravitational units? Because it's not like a normal force. It's because of the Earth's gravitational force. Okay. So if you take the gravitational units, we just call it as kilogram weight. It is also called kilogram force. This is SI unit. And gram weight or gram force. This is CGS unit. Any doubt in this, Gautam?
No, no doubt, ma'am.
For normal force, we take newtons and dynes. If you take weight, it's a kind of gravitational force, right? So we have some other system of units, that is gravitational units. And what is the gravitational unit for weight? In SI system, kilogram weight, also called as kilogram force. In CGS system, gram weight, also called gram force. Is this point clear?
Yes, ma'am.
Any doubt in this?
No, no doubt, ma'am.
Now, some 10 important points to remember. So 1 kilogram weight is equals to how many newtons? 9.8 newtons, remember. And 1 gram weight is equals to how many dynes? It is 980 dynes. You have
Yes,
to
ma'am.
you have to remember the related formulas. 1 kilogram weight is equals to 9.8 newtons. 1 gram weight is equals to 980 dynes.
Yes, ma'am.
Any doubt in this?
No, no doubt, ma'am.
Okay. Now, so tell me, what are the gravitational units of weight?
Ma'am, gravitation, gram, ma'am. Gram by weight.
What are the gravitational units of weight?
Yeah, ma'am. Dyne and Newton.
Dyne and Newton are the general units for force. I'm asking you gravitational units. Kilogram weight and gram weight. Okay.
Yeah, ma'am. Yes, ma'am.
Kilogram weight and gram weight.
Gram.
1
Okay.
kilogram weight is equals to how many newtons?
9.8.
9.8. 1 gram weight is equals to how many dynes?
9.8.
980 dynes. Which is scalar, mass or weight?
Scalar is mass, ma'am.
Vector is
Weight.
weight. What is the formula for weight?
Mass into acceleration. No.
Mass
Yes, ma'am.
into acceleration due to gravity. W is equals to m into g. What is g value on earth?
9.8.
9.8 meter per second square. So tell me, what are the gravitational units of weight once again?
Ma'am, kilogram by weight and gram.
Not by, kilogram into weight, gram into weight, kilogram weight, gram weight. Okay.
Yes, ma'am.
So Newton's third law of motion. You have any idea about this?
Ma'am, every action has an equal and a
Exactly. Every action has an equal and opposite reaction. Okay. See, for suppose, imagine your mama told you to read. So you will start reading. Imagine that your mama scolded you that you have to read a lot. Then what will you do? You will read a lot, isn't it? So mama scolding you is action and your reading is reaction. So how much mama will scold, that much you will read, isn't it?
Yes,
So,
ma'am.
so the same way here, when you take physics point of view, whenever two objects are interacting, Gautam, the two objects exert force on each other. Okay. For suppose, let me take, this is first object in contact with second object. Okay. Now the force exerted by first object on second object is denoted as F12. Similarly, force exerted by the second object on first object is
Yes,
denoted as F21. Is it clear?
yes, ma'am.
Okay. Now what Newton's third law says is, first body exerts force on second body also exerts force on first body, and these two forces will be what? Equal and opposite in direction.
Yes, ma'am.
So it says that for every action there is an equal and opposite reaction. So what does it mean? It means if I take this present example, F12 will be equal to what? F21, magnitude wise. Okay. And what about their direction? Both will be opposite to each other.
Yes, ma'am.
Okay. If I take modulus, what does it mean? If I keep this modulus symbol, it means I'm considering only magnitude. Okay. If you take this expression, above expression, what I have written, I kept modulus. That means only magnitude of forces is equal, but direction will be opposite. If you don't keep this modulus, what you have to do is, Gautam, F12 will be equal to F21, opposite in direction, so I have to keep minus.
Yes, ma'am.
If
Action is equal to minus here.
Yeah, if you keep modulus, don't keep minus. If you keep modulus, it means only magnitude. You are talking only about magnitude. If you don't keep modulus, then you are talking about the overall thing, magnitude, also direction. Okay. So this
Okay.
negative sign indicates what? It indicates opposite direction.
Yes, ma'am.
Any doubt in this?
No, no, no.
Okay, action force, reaction force, both will be equal in magnitude and opposite in direction. And what do we call these two forces now, which are in equal magnitude but opposite in direction? Now these two pair of forces are called action reaction pair. First force, second force, what do we call them? They are called action reaction pair.
Yes, ma'am.
Okay, any doubt in this?
No, no.
Okay.
Ma'am, can you tell what is action there?
Action reaction in the sense forces only. First force is called action force, second force is called reaction force.
Okay, ma'am.
Like if you take here now, what is F12? This is force applied by first body and second body. This is F12. Now this F12 is called action force. Now second
Yes,
body is also applying force on first body. How is it denoted? It is denoted as F21. Now this F21 is reaction force.
yes, ma'am.
Now if you take two forces, it's nothing but a pair, no?
Yes, ma'am.
So you are taking pair of two forces. One is action force, the other is reaction force. So if you consider both the forces, what do we call that pair? Action reaction pair.
Yes, ma'am.
Okay, simply pair of two forces. Okay. And
Yes, ma'am.
what is the condition for this Newton's third law of motion? Are the two forces acting on the same body or different bodies?
Different.
That is a condition here. What is the condition for Newton's third law of motion? The two forces must act on different bodies. If both of them are acting on the same body, it is not considered under Newton's third law of motion. Clear?
Yes, ma'am.
Any doubt?
No, no, no.
Okay. So can you repeat what is Newton's third law of motion?
Ma'am, every action has an equal and an
Equivalent
opposite reaction.
opposite reaction. How do you mention the direction mathematically?
They are opposite, ma'am. Action is equal to negative of reaction.
Yeah, you have to use minus symbol for representing the opposite in direction. Okay. Now we'll
Yes.
see the examples or applications of Newton's third law. Okay. So let
Yes.
me take a table. Okay. Now let us keep a book on the table. So book will be having a mass m, right? So can you tell me, due to force of gravity, so what will be acting down? Weight will be acting down, whose formula is m into g, right?
Yes, ma'am.
Now yesterday I told you there are different types of contact forces, and one is a normal force, and normal force is a perpendicular force where we consider the contact. At the contact, perpendicular force is normal force. Okay. So book is kept horizontally, so how will be the perpendicular force? Perpendicular force will be in upward direction of. So this is your normal reaction, right?
Yes, ma'am.
Now, now your book is in rest position. So the opposite forces must be equal. Upward force is N, downward force is mg. Now these two forces are equal, right?
Yes, ma'am.
Now this weight I can consider as action force. This normal reaction I can consider as what?
React.
Reaction force. Now you see here N is equals to mg. That means action force, reaction force both are equal. And you see their directions. Are they in opposite directions or not?
Yes, ma'am.
So action is in downward direction, reaction is in upward direction. So this is an example of what? Newton's third law of motion.
Yes, ma'am.
Okay. And another example. So if you take a swimmer, so what does the swimmer do in order to move forward?
We push the water outside, ma'am.
Yeah. So imagine Gautam is swimming, okay? So he is pushing the water backward, right?
Yes, ma'am.
Pushing water backward direction. So this pull or push is nothing but our force. Now what water will do? Water will push you forward. Now you are pushed forward by water. Right, Gautam?
Yes, ma'am.
So we are pushing the water backward and water is pushing us forward. So we pushing the water backward is called which force? This is called action force. And water pushing us forward is called which force? It is called reaction force. So action force, reaction force, both will be equal in magnitude. And if you see here, forward, backward, opposite in direction. Clear?
Yes, ma'am.
Now the same thing you can consider even for walking also. So walking, what do we do? Just similar to the case of swimming, but here we are walking on the road. Okay. So you are walking forward, that means you are applying force on the ground in backward direction. Okay.
Yes,
You
ma'am.
apply force on ground in which direction?
Backward direction.
In backward direction. Now ground will push you in which direction?
And forward direction.
Yeah, you are pushed now in forward direction. So which is action force, which is reaction force here?
Ma'am, here myself applying force on the ground backward is.
Exactly. So this is your action force and you walking forward will be what? Will be reaction force. Now if you see here both the directions are opposite and here also we can see equal in magnitude of the forces. So this is also example of what? Newton's third law of motion. Clear?
Yes, ma'am.
Now in your textbook some other examples are also given. Like offshore, like when we reach the end point of a river and when we just want to jump out of the boat, when we jump out of the boat, what do we do exactly there? We push the boat backward and the
Yes,
boat
ma'am.
pushes us forward.
Yes, ma'am.
So this is the land and imagine this is the water body. Okay, so
Yes, ma'am.
you are in the boat. Now you are jumping out of the boat. Okay, so when you are jumping, what happens? You push the boat backward. So boat
Goes front.
backward and you will be moving what? You will be moving forward.
Forward.
So which is action force here? Backward is Fa, action force. Forward is Fr, reaction force. So action force, reaction force, both are equal in magnitude and both of them are in opposite direction. Okay.
Yes, ma'am.
And fifth example is recoil of gun. Recoiling means moving backward.
Yes, ma'am.
What is the meaning of recoiling? It means moving back. Okay, so when you fire a bullet from a gun, the gun gives you a jerk in backward direction. So whenever you trigger the bullet from the gun, what happens? Bullet moves in forward direction, but the gun will give you a jerk in backward direction. What's the reason for that?
Newton.
So you can see some trigger point here. You will be pressing this, right?
Yes, ma'am.
So when you press, what happens? This is the bullet which is moving in forward direction. Now this gun portion will give a jerk in backward direction.
Yes,
So
ma'am.
this is also because of Newton's third law. Forward bullet moving forward is action force Fa. Gun giving jerk in backward direction is reaction force. This gun moving back is called what, beta? Recoiling of the gun. Okay.
Recoil. Yes.
Yeah. In your textbook, rocket is an example of Newton's third law of motion, Gautam, but that is wrong. Rocket is not an example of Newton's third law of motion. It was given in your textbook, but in higher classes you will come to know that it is not an example. Okay. See why?
Okay.
Because what is a condition for Newton's third law? Action force and reaction force both must be on two different bodies, right?
Yes, ma'am.
If you take rocket launching, I'll just take a new word. So if you take rocket launching, what do they do in rocket launching? So they just keep some cylinders. So one will be having fuel which burns and the other will be having oxygen supporter. So when these two interact, what happens? The fuel undergoes combustion and the gases will come out, right?
Yes, ma'am.
So this was given as the action force. As a result of that, the rocket will move upward. This is given as reaction force, right? But if you
Yes.
see, both the forces are present in which body? On the same body, no?
Yes,
Action
ma'am.
force is also on the same rocket, reaction force is also on the same rocket. But
Ma'am, but the action is on did on ground right now. It is attached to ground. So
it is not actually attached to the ground. If you take action force, no, the rocket body has to apply some force here. But where is the rocket applying some force? Just fuel is coming out, that's it. The
okay, ma'am.
reaction force is correct. When the gases are coming out, these gases are pushing this rocket upward, right?
Yes, ma'am.
In the sense, this rocket must push the gases out, right? Is the rocket really pushing the gases out?
No, ma'am.
What is the action and reaction force? The two bodies which are in contact. First body must apply force on second body, and second body must apply force on first body. If you see reaction force, that is fine. The gases are coming out, and these gases are pushing the rocket forward. So that
Yes,
is
ma'am.
fine. Gases exerting force on rocket, fine. That is fine. That means rocket body must exert some force on the gases. No, where is the force exerted? There is no force exerted here. No force exerted. Here we have only F21, force applied by second body and first body, but there is no F12. There is no force applied by first body and second body. It is simply combustion of fuels. That's it.
Yes, ma'am.
Okay. In most of the books, it will be given as an example, but this is not true.
Okay, ma'am.
Okay. This is simply an example for momentum. Did you
Yes, ma'am.
understand my point, Gautam?
Yes, ma'am.
ఏ టూ బాడీస్ అయితే కాంటాక్ట్లో ఉంటాయో ఒకదాని మీద ఒకటి ఫోర్స్ అప్లై చేసుకోవాలి. మనకు
Yes,
రాకెట్ లోపల గ్యాసెస్ అనేవి బర్న్ అయ్యి ఆ గ్యాసెస్ బయటికి రావడం వల్ల అవి ఒక పుష్ ఇవ్వడం వల్ల రాకెట్ పైకి పోతుంది. ఆ
yes,
పుష్ని మనం రియాక్షన్ ఫోర్స్గా తీసుకుంటాం. ఇప్పుడు మనకు రాకెట్ మీద ఎవరు ఫోర్స్ అప్లై చేస్తున్నారు? గ్యాసెస్ కదా.
yes, ma'am.
అంటే అప్పుడు గ్యాసెస్ మీద కూడా మనకు రాకెట్ కొంచెం ఫోర్స్ అప్లై చేస్తుందా?
చేయట్లేదు.
చేయట్లేదు. గ్యాసెస్ రాకెట్ మీద పుష్ని అప్లై చేస్తున్నాయి కాబట్టి రాకెట్ పైకి పోతుంది.
Yes, ma'am.
రాకెట్ గ్యాసెస్ మీద ఎక్కడ పుష్ అప్లై చేస్తుంది? చేయట్లేదు కదా.
Yes, ma'am.
There is force applied by second body on first body, but first body is not applying any force on second body. It is simply just the burning of gases.
Yes, ma'am.
Okay. And when gases are burning, they are just exerting pressure on the surrounding air.
Yes, ma'am.
That's it. Okay.
Yes, ma'am.
Getting my point?
Yes, ma'am.
Okay, fine. Like as you said, no చెప్పిన example తీసుకున్నా, the gases are exerting pressure on the ground when
Yes, ma'am.
gases are coming out. Okay. So the ground must move, right? What is the object that is moving? Rocket is moving.
Rocket. Yes, ma'am.
కాబట్టి ఇక్కడ గ్రౌండ్ తో ఏం సంబంధం లేదు.
Okay, ma'am.
ఓకే. So this was given, but it is actually wrong. Maybe for your standard they will consider. చాలా బుక్స్లో ఇట్లా ఇస్తాడు. మేబీ మీ క్లాస్ లెవెల్కి కన్సిడర్ చేయొచ్చేమో, బట్ హయ్యర్ క్లాసెస్లో నువ్వు చదువుకుంటావు. దిస్ ఈస్ అన్ ఎగ్జాంపుల్ ఫర్ మొమెంటమ్ యాక్చువల్లీ. ఓకే,
ఓకే మ్యామ్.
ఇప్పుడు ఏం చేసేది లేదు కాబట్టి నీ క్లాస్లో ఇది నువ్వు ఇది ఫాలోగా అంతే, జస్ట్ గుర్తు పెట్టుకో అంతే. ఓకే, and
ఓకే.
what is the use of this rockets? They will send some satellites. ఇప్పుడు మనకు GPS ఉంటుంది. That GPS is working because of the satellites. Okay, so all useful information, broadcasting, all those will be done with the help of satellites, and those satellites are carried to the space with the help of the rockets. Okay,
Yes, ma'am.
now open your textbook. There are some questions. We'll do them.
Yes, ma'am. Yes, ma'am.
Okay, so a block of weight 5 newtons is placed on a horizontal table. So let this be a table. A block is kept on the table, and what of weight? So this is the block weight, in the sense what? M into G, right? So
Yes, ma'am.
this W is equals to M into G. So this weight is given as 5 newtons. Fine. A person pushes the block from top by exerting a downward force. So a person from the top is applying a push in downward direction. Fine. How much force? It is equals to 3 newtons. Find the force exerted by table on the body. By table on the body. So what will be the direction? This is the table on the body. So it will be in upward direction, right?
Yes, ma'am.
This is the point of contact. So table exerting force on the block. So what will be the direction in that case? It will be in upward direction. So simply you need to find upward force. Getting my point, Gautam?
Yes, ma'am.
Now, how do we do this? As I told you, when the body is in rest position, there will be balancing of forces. That means top force will be equal to bottom force, left force will be equal to right force. Left right time forces leave ikkada. Kabatti you have to take upward forces equal to downward forces. Forces acting in upward direction will be equal to forces acting in downward direction. So what are the forces acting in upward direction? Only this question mark, right? Force exerted by table on block. Okay, and what is the
Yes.
downward force? First downward force is weight mg, that is 5 newtons. Second downward force is person exerting. So 5 plus 3, how much? 8 newtons.
Yes, ma'am.
Therefore force exerted by table on block is equals to 8 newtons. This is the answer.
Yes, ma'am.
Clear?
Yes, ma'am.
Even if there is a small doubt, ask me, Gautam. Tomorrow we will do all problems.
Okay, ma'am.
Now go through the next question that is given in your textbook. What was question 2? A block of mass 50 kg is kept on a floor. Okay, so this is a floor, let us assume. Now a block is kept on this floor whose mass is how much? 50 kg. Now Rama is trying to push it from the left and Krishna is trying to push it from the right. Okay, so there are two people. Let this be Rama pushing from the left, and let this be Krishna pushing from right. From which direction? Right side direction. Okay, the forces exerted by them are 25 newtons and 35 newtons respectively. So Rama is applying 25 newtons and Krishna is applying how much? 35 newtons. Find the force of friction so that block remains stationary on the floor. So what will be the direction of frictional force, Gautam?
To the side of Krishna, ma'am. Where right side.
Yeah, friction opposes the motion of the body, right?
Yes, ma'am.
Friction opposes motion of the body. So first of
Rel-
all, we have to find where the motion of the body is. First we have to find the direction of motion of the body.
Ma'am, relative.
Yeah, if I take this as a body, left side 25 newtons force, right side 35 newtons force. There is no upward and downward force here. You have to take left and right here. So left and right, what is the difference? Left side 25, right side 35. So which force is more here?
Krishna's side, left
Krishna's
side.
force. So
Yes.
Krishna is applying 35 newtons. Out of that 35, 25 will neutralize. So remaining 10 newtons will dominate and the body will move in which direction? It will move in
Rama's
opposite
direct.
direction. Yeah. So this is the direction of motion. Direction of motion of the body. Now what will be the direction of friction? Friction opposes the motion. Motion is towards left.
To the Krishna side.
Yeah, motion is towards left. So what will be the direction of friction now? This is the direction of friction. It will be towards right. Okay. Now what is the condition? The body has to remain stationary. The body should stop. So how much frictional force we must apply?
More 10.
You have to apply 10 newtons. Okay. That side also 10 newtons. This side also 10 newtons. Then the body will not move. Do you remember I told you in friction, frictional force is a self-adjusting force.
Yes, ma'am.
When the body is in rest position, frictional value is nothing but external force. So here external force is 10. So frictional value is also how much? 10 newtons.
Yes, ma'am.
More than 10 newtons. If you apply friction, if frictional force is more than 10, then what happens? It will move towards right. It must be exactly equal to 10. Then it will not move left, it will not move right.
Yes, ma'am.
Okay, more than, not more than 10, equal to 10. Okay, మోర్ దెన్
Yes.
10 అయితే ఏమవుతుంది? ఫ్రిక్షనల్ ఫోర్స్ వల్ల అది ముందుకు వెళ్ళిపోతుంది. కరెక్ట్గా 10 ఉంటేనే ముందుకి పోదు, వెనకకి పోదు.
Yes,
Clear?
yes.
Is this point clear? So how much is the frictional force? 10 newtons. And what is its direction? Towards the right, that is towards Krishna. Okay,
Yes, ma'am.
any doubt in this?
No, no, no.
Okay, now we just need to understand certain basic things for problems. Okay, so first thing, yesterday I told you, no, contact force, the force which comes into play when there is a physical contact between two interacting objects. Okay, so there are two important forces that you need to remember compulsory. One is normal reaction. It is denoted as N. In your textbook it is denoted as R. Anyone is fine. Okay, and
Yes,
second
ma'am.
important force is frictional force, denoted as small f. Okay, so what is this normal force and frictional force? Let me take a body which is kept in contact with the surface. Okay,
Yes, ma'am.
now wherever there is a contact, if you take perpendicular force, that is your normal reaction. అంటే కాంటాక్ట్ ఉన్న చోట 90 degrees లో ఉండే ఫోర్స్ ని మనం నార్మల్ రియాక్షన్ అంటాం.
Yes,
So
ma'am.
if you see here, the body is kept horizontally on the table, right?
Yes, ma'am.
Body is kept horizontally on the table. సో హారిజంటల్ లైన్ ఉన్నప్పుడు పర్పెండిక్యులర్ ఎట్లా వస్తుంది? వర్టికల్గా వస్తుంది. అప్పుడే 90 degrees యాంగిల్ ఉంటుంది. ఓకే, సో నార్మల్ రియాక్షన్ విల్ బి అప్వర్డ్. ఇస్ దిస్ ఫైన్?
Yes, ma'am.
Now, so normal reaction is a perpendicular force at the point of contact. At point of contact. Okay,
Yes,
మీకు
ma'am.
ఒక డౌట్ రావచ్చు, మేడం ఇక్కడంతా కాంటాక్ట్ ఉంది కదా, మరి ప్రతి చోట తీసుకుంటామంటే అవసరం లేదు. సెంటర్ ఆఫ్ ద బాడీ నుంచి తీసుకుంటాం. ఒక పాయింట్ దగ్గర తీసుకుంటే చాలు. బికాస్ ద హోల్ మాస్ ఆఫ్ ద బాడీ కాన్సన్ట్రేట్స్ అట్ ది సెంటర్.
Yes,
సో
ma'am.
సెంటర్ పాయింట్ దగ్గర తీసుకుంటాం. ఓకే, ఫ్రిక్షనల్
Yes,
ఫోర్స్. వాట్ ఈస్ ఫ్రిక్షనల్ ఫోర్స్? ఇట్స్ అ టాంజెన్షియల్ ఫోర్స్ విచ్ యాక్ట్స్ ఆపోజిట్ ఇన్ డైరెక్షన్. సో ఇప్పుడు సేమ్ డయాగ్రామ్ తీసుకుంటే, సో పాయింట్ ఆఫ్ కాంటాక్ట్ దగ్గర ఆపోజిట్ డైరెక్షన్. ఫర్ సపోజ్ బాడీ మూమెంట్, if we assume that it is in forward direction, then tangentially backward direction is what? Frictional force.
frictional force. Yes, ma'am.
Okay, tangential force and opposite to motion of the body. Is this clear?
Yes, ma'am.
Perpendicular force is normal reaction, tangential force is frictional force. దీంట్లో ఏమైనా డౌట్ ఉందా?
No, no doubt, ma'am.
ఓకే, టెక్స్ట్ బుక్ ఓపెన్ చేయ ఒకసారి. So there are two examples in your textbook. Open them, Gautam.
Yes, ma'am.
So first example, two blocks are kept in contact on a smooth surface as shown in figure. Draw normal force exerted by A on B. So this is the diagram. Okay, A and B. Okay, so if you see the diagram, is there any push or is there any pull?
No, ma'am.
No. So there is no push, there is no pull. So we don't know exactly what is the position of the bodies when they are in motion, right?
Yes, ma'am.
ఓకే. సో, అట్లా ఉన్నప్పుడు మనకు పాయింట్ ఆఫ్ కాంటాక్ట్ ఎక్కడో తెలియదు. తెలియనప్పుడు నార్మల్ రియాక్షన్‌ని చెప్పలేం. ఫర్ సపోజ్ ఇఫ్ ఐ అస్యూమ్ దట్ దీస్ 2 బాడీస్ ఆర్ ఇన్ రెస్ట్ పొజిషన్, then weight will be acting downward. Then in that case you can say normal reaction is in upward direction.
Yes, ma'am. Here they didn't mention.
So they said exerted by A on B, but we don't know how much force is exerted by A on B and in which direction మనకి ఏది తెలియదు. సో తెలియనప్పుడు మనం చెప్పలేం. ఓకే.
Yes, ma'am.
Is it
We can
clear?
say it's simply zero.
యా సింప్లీ జీరో చెప్పలేము అంటే జీరో అన్నట్టు. ఓకే.
Yes, ma'am.
See the next question. Draw normal forces on the massive rod at point 1 and point 2 as shown in the figure. Now if you see the second question, they did not mention. So whether it is in motion or whether it is in rest. So we can keep the answer now. So because they did not specify no motion or rest. So we just consider it is in rest position. And we consider normal force because of the weight.
Ma'am, in previous question also they didn't mention it is.
They have mentioned draw the normal force exerted by A on B.
Oh, me. Okay, ma'am.
When do you get such words exerted by A on B? When they are in motion, no?
Motion. Okay,
But
ma'am.
but here in the figure they have not mentioned in which direction it was.
Yes, ma'am.
Okay. Now, so this is the point 1 and this is the point 2. So what will be the direction of normal force? At the point of contact you have to take perpendicular force. So this point is on horizontal line, so normal will be in perpendicular line. So here also this point is in contact horizontally, so what will be the direction of normal force? Perpendicularly. Okay. For suppose if I take any point in between, now this is not horizontal, right?
Yes, ma'am.
This is on inclined plane. So on inclined plane what will you do? You just have to shift this, make it horizontal. నీకు ఒక్కసారి చూపిస్తాను. I'll just on the video. Wait a minute. Now we'll just continue. So in your textbook, second point, this is the second point in your textbook. I'm just mentioning it as 3, but this is the one that is asked in your textbook. So what will be the direction of normal reaction? Now I'll just assume it horizontal. Now this is how will be my normal.
Yes, ma'am.
Getting my point?
Yes, ma'am.
So if the point of contact is horizontal, normal will be vertical line, perpendicular line. If the point of contact is along the inclined plane, then there also you have to make sure that the angle is 90 degrees. Okay. So
Yes.
whatever you take, normal must be a perpendicular line. Okay.
Yes, ma'am.
Any doubt in this?
No, no doubt.
Okay. Now, I'll just make a correction in your previous question, Gautam. Actually, the question itself is also wrong. Mm, the question must not be like this, Gautam. The diagram must be like this. అందుకే కన్ఫ్యూజన్ వస్తుంది. So this is block A, this is block B. Now is there any point of contact between A and B?
No, ma'am.
No, that's why normal force is 0.
In question they gave they are attached
They
inside.
are attached, అందుకే తప్పు వస్తుంది. Okay. So if this is how this is how the diagram must be in your textbook. Okay.
Yes, ma'am.
So if they are in contact, then the contact force normal will come into the scenario, but they are not in contact. So that's why there won't be any normal reaction. పైన ఇచ్చినట్టు డయాగ్రామ్ కన్సిడర్ చేసినాం అనుకో అప్పుడు ఆన్సర్ ఇది అవుతుంది A B. Okay, so what is the normal force exerted by A on B? Okay, so A on B force ఇలా ఉంటే నార్మల్ రియాక్షన్ దానికి ఆపోజిట్ ఉంటుంది.
Yes, ma'am.
Okay, clear?
Yes, ma'am.
So textbook, there must be some gap here. So any doubt so far?
No, no doubt.
Okay. Then we'll go for the topic free body diagram. Very, very important. So you have any idea about free body diagram?
Free body diagram. It represents all the forces acting.
Exactly. So free body diagram is a diagram or it's a representation of a body diagrammatically. So which shows all the forces acting on it. Okay. So it is called as FBD. FBD means free body diagram short form. What is this diagram? It shows all the forces acting on it. All the forces acting on the body. Okay. So there are certain things that we consider here. So object will be taken as point. This is how object will be considered. Okay.
Yes, ma'am.
Now for example, some examples are given in your book. Like if you take the same example, book is kept on a table. Book on a table. So how do we represent the free body diagram for this? So book is the object. So because of the book's weight, there is a force W which acts in downward direction mg. Now book, table, both are in contact. So when they are in contact, which force will come? Normal force will come. And what is the direction of normal force? It is a perpendicular force. Book is along the horizontal, so normal will be vertical now. Got my
Yes, ma'am.
point clear?
Yes, ma'am.
So this is the way of representing the free body diagram. Now one more example. So on a floor, there are two bodies A and B. So they are connected with a string. This is your string. Okay. Now for this you have to draw the free body diagram. There is some force which is acting on the body B. B block is pulled in the forward direction. Okay. So how
Yes,
do we
ma'am.
represent the free body diagram? First let us take A. We'll take for A body. So A has some mass. So mg. And there is a point of contact here. So definitely there will be normal reaction N. Now F is pulling the block B. But B is interconnected with A, right?
String.
Now
Yes,
they are
ma'am.
connected with the string. The force present in the string is called tension force. Okay. It is denoted as T, and remember tension force always acts away from the objects.
Away.
Away
Okay.
from the objects. Object ki opposite direction lo ఉంటుంది. For suppose if you see here, A and B are connected with the string. So tension on the A will be away from A. Tension on B will be away from B. This is tension on A away from the A. This is tension on B away from B. So ikkada tension on the block A. Any doubt
Yes, ma'am.
in this, Gautam? String లో springs లో ఎలాస్టిసిటీ ఉన్న ఏ దాంట్లో అయినా మనం కన్సిడర్ చేసే ఫోర్స్ పేరేంటి? టెన్షన్ ఫోర్స్. దానికి సింబల్ టీ. ఎప్పుడు టెన్షన్ ఎట్లా ఉంటుంది? ఆబ్జెక్ట్స్ కి దూరంలో ఉంటుంది, అంటే ఆబ్జెక్ట్స్ కి దగ్గరికి పోకుండా ఎవేగా ఉంటుంది.
Okay,
ఓకే.
ma'am.
సో ఇప్పుడు బ్లాక్ ఏ బ్లాక్ బి కనెక్ట్ అయినాయి. సో బ్లాక్ ఏ ఇది, బ్లాక్ బి ఇది, ఇలా కనెక్ట్ అయినాయి స్ట్రింగ్ తోటి. ఇప్పుడు టెన్షన్ ఆన్ ఏ ఏం తీసుకోవాలి? ఏకి దూరంగా తీసుకోవాలి, అంటే ఇటు వెళ్ళిపోవాలి. దిస్ ఈస్ టెన్షన్ ఆన్ ఏ. ఓకే.
అంటే ఆ సైడ్ కూడా రావచ్చు.
అది
It
వచ్చేది,
can.
అది డ్యూ టు బి. టెన్షన్ ఆన్ బి అది.
Okay, ma'am.
ఓకే. ఫర్ సపోజ్ యు ఆర్ టేకింగ్ ఏ అండ్ బి కనెక్టెడ్ విత్ ద స్ట్రింగ్. ఇటు సైడ్ వచ్చేది ఏమవుతుంది? దిస్ ఈస్ టెన్షన్ యాక్టింగ్ ఆన్ బి.
Yes, ma'am.
Tension force is present in opposite direction also, but that tension is considered for which body? B body.
Yes, ma'am.
ఓకే. సో ఇప్పుడు ఏ బాడీ తీసుకుంటే downward direction mg, upward direction normal force, and towards the right side we have tension force. Any doubt in this?
No doubt.
Okay. Now let us take for B body. Okay. So B body తీసుకుంటే B also has some mass. So mg in downward direction, upward normal reaction. Now B is also connected with wire. So that will also have tension force. So away from B, tension TB, and some external force is acting on B in right direction. So this is F.
Okay, ma'am.
Got this point?
Yes, ma'am.
Any doubt?
No doubt, ma'am. Ma'am, but tension force can act on side of force also.
Tension force can act on side of force also. Side of force, do you have any wire?
Yeah, no, no, I am not.
వైర్ ఉన్న చోట మాత్రమే టెన్షన్ ఫోర్స్ ఉంటుంది. బి తర్వాత మనకు ఏ వైర్ లేదు కదా. బీని పట్టుకొని ఎవరో లాగుతున్నారు, అది
Okay,
ఎక్స్టర్నల్ ఫోర్స్. కానీ బీకి ఎఫ్కి మధ్యలో ఏం వైర్ లేదు.
లేదు. Okay, ma'am. Now I understand.
ఎవరో బీని పుల్ చేస్తున్నారు, అక్కడ ఏం వైర్ లేదు. వైర్ లేకుండా టెన్షన్ ఫోర్స్ ఉండదు, వైర్ ఉంటేనే టెన్షన్ ఫోర్స్. వైర్ కానీ స్ప్రింగ్స్ కానీ ఏమైనా ఉంటే అప్పుడు టెన్షన్ టీ అనేది వస్తుంది.
Yes, ma'am.
ఇంకేమైనా డౌట్స్ ఉన్నాయా?
No, no doubt, ma'am.
ఏం డౌట్స్ ఉన్నా అడుగు. ఓకే, సో ఆర్ యూ
Okay, ma'am.
క్లియర్ విత్ దిస్ ఫ్రీ బాడీ డయాగ్రామ్?
Yes, ma'am.
Okay. When we are solving the problems, you have to construct the free body diagram. And how do you solve the problems? For solving the problems, you have to take net force is equals to M into A. So for numericals, what are the steps that you have to consider is, first construct the free body diagram and apply it individually for every block. That means if you take the previous example, A and B are interconnected. You have to take free body diagram A separately, B separately. Individually, you have to take the free body diagrams. Then you have to take balancing of forces. Okay.
Yes, ma'am.
And at the same time, you have to equate F net is equals to M into A. That means you have to take the net force acting in vertical direction equal to M into A. You have to net force acting in horizontal direction, that is equals to M into A. In your textbook, along x-axis, along y-axis, along z-axis అని ఇచ్చినారు, అంత అవసరం లేదు. F net will be equal to M into A. అది గుర్తుపెట్టుకో.
Yes, ma'am.
Okay. Now we'll do different cases. Formula is important, Gautam. కానీ how we are getting the formula is important in problems. కొన్నిసార్లు నీకు డైరెక్ట్గా నీకు ఫార్ములా బేస్ ఉండదు, కాన్సెప్ట్ బేస్ ఉంటాయి ప్రాబ్లమ్స్. సో అటువంటిప్పుడు కాన్సెప్ట్ గుర్తుపెట్టుకో. దిస్ ఈస్ ది స్టెప్. ఫస్ట్ ఫ్రీ బాడీ డయాగ్రామ్, దెన్ ఇండివిజువల్లీ ఫర్ ఎవ్రీ బాడీ యూ హ్యావ్ టు టేక్ ది బ్యాలెన్సింగ్ ఆఫ్ ఫోర్సెస్. బ్యాలెన్సింగ్ ఆఫ్ ఫోర్సెస్ అంటే ఏంటి? ఇక్కడ అప్వర్డ్ ఫోర్స్ విల్ బీ ఈక్వల్ టు డౌన్వర్డ్ ఫోర్స్. ఓకే. ఫోర్సెస్
Okay, ma'am.
యాక్టింగ్ ఇన్ రైట్ డైరెక్షన్ విల్ బీ ఈక్వల్ టు ఫోర్సెస్ యాక్టింగ్ ఇన్ లెఫ్ట్ సైడ్ డైరెక్షన్. ఓకే.
Yes, ma'am.
Now if you consider acceleration for the body, అప్పుడు ఏం చేయాలి? F net will be equal to M into A. ఇది ఎప్పుడు
Ma'am, can you
వస్తుంది?
repeat it again?
When body is in motion, బాడీ మూవ్ అవుతుంది అనుకో, అప్పుడు దానికి ఏముంటుంది? వెలాసిటీ ఉంటుంది, యాక్సిలరేషన్ కూడా ఉంటుంది. అప్పుడు నువ్వు ఏం
Yes.
చేయాలి? F net is equals to M into A అని చెప్పి తీసుకోవాలి.
Okay, ma'am.
ఇది ఎప్పుడు? వెన్ బాడీ యాక్సిలరేషన్ ఇస్ జీరో, అంటే బాడీ మూవ్ అవ్వట్లేదు, రెస్ట్ పొజిషన్లో ఉంది. అప్పుడు అప్వర్డ్ ఫోర్సెస్ డౌన్వర్డ్ ఫోర్సెస్ ఈక్వల్ ఉంటాయి. రైట్ సైడ్ ఫోర్సెస్ లెఫ్ట్ సైడ్ ఫోర్సెస్ ఈక్వల్ ఉంటాయి. ఒకవేళ బాడీ కదులుతుంది అనుకో, కదులుతున్నప్పుడు ఏమవుతుంది? దానికి యాక్సిలరేషన్ ఉంటుంది. అప్పుడు నువ్వు ఏం
Yes.
చేయాలంటే ఎఫ్ అప్ ఎఫ్ డౌన్ ఈక్వల్ చేసుకోకూడదు, నెట్ ఫోర్స్ తీసుకోవాలి. అంటే నీకు ఇందాక వీ డిడ్ సమ్ ప్రీవియస్ ఎగ్జాంపుల్ 25 న్యూటన్స్ బై రామ, 35 న్యూటన్స్ బై కృష్ణ. సో వాట్ ఈస్ ఎఫ్ నెట్ దేర్? 35 minus 25.
Yes, ma'am. Because they are in opposite.
సో అది ఎఫ్ నెట్. ఆ ఎఫ్ నెట్ ఇక్కడ ఏం చేయాలంటే ఎం ఇంటూ ఏకి ఈక్వల్ చేసుకోవాలి, ఎందుకంటే బాడీ కదులుతుంది. ఇప్పుడు కదులుతున్నప్పుడు ఎఫ్ నెట్ మస్ట్ బి ఈక్వేటెడ్ టు ఎం ఇంటూ ఏ.
Yes,
we
ma'am.
will do, Gautam, we will do cases, then you will understand. Okay.
Yes, ma'am.
So formula is important, but we will see the procedure also, because procedure will help you to solve the problems. So first case, this is the first case. There is a surface and two bodies are in contact now. First body mass m1, second body mass m2. Some external force F is applied on first body, second body. Okay. సో ఎఫ్ ఎక్స్టర్నల్ ఇప్పుడు చూడు, బాడీ మీద ఫోర్స్ అప్లై చేసినప్పుడు బాడీ మూవ్ అవుతుందా అవ్వదా?
అవుతుంది.
అవుతుంది. సో ద బాడీ మూవ్స్ ఇన్ ఫార్వర్డ్ డైరెక్షన్. Now the two bodies are interconnected, right?
Yes, ma'am.
So if M1 is moving, M2 also moves in the same direction, right? Because both are interconnected.
Yes, ma'am.
Okay. Now move అవుతుంది అంటే now what you have to do? You have to remember that F net must be equated to what? M into A. Because move అవుతుంది అంటే యాక్సిలరేషన్ ఉంటుంది కాబట్టి F net must be equated to MA. Is this point clear?
Yes, ma'am.
Any doubt in this?
No, no doubt, ma'am.
Okay. Now, so the body moves in forward direction with acceleration A. ఇక్కడ acceleration of first body is also equal to acceleration of second body because both are interconnected. So both will have the same acceleration.
Yes, ma'am.
ఓకే, ఒకవేళ మధ్యలో వైర్ కానీ స్ప్రింగ్ కానీ అట్లేమైనా ఉంటే సేమ్ యాక్సిలరేషన్ ఉండదు. రెండు
Okay.
ఒకదానికొకటి అతుక్కొని ఉన్నాయి కాబట్టి రెండింటికి సేమ్ యాక్సిలరేషనే ఉంటుంది. ఓకే,
Okay.
సో యూజ్ దిస్ ఫార్ములా F is equals to M into A. Now A is equals to what? F by M, right?
Yes, ma'am.
Now force is F. What is mass here?
M1 plus M2.
Very good. There are two bodies interconnected, so we have to take the total mass. So
Now,
what
if
is
there are three bodies means plus M3.
plus M3 exactly. So what is acceleration of F applied by M1 plus M2? This is the acceleration of both the bodies. Any
Yes,
doubt
ma'am.
in this?
No, no doubt, ma'am.
Okay. Now similarly, for suppose if you want to find, see, this force is applied on which body?
On both the.
Directly on M1 body. Of
Yes,
course, on
ma'am.
both the bodies, but direct in contact with M1 body. Now the
Yes, ma'am.
same force is applied by M1 on M2 body, right?
Yes, ma'am.
Same force F is applied by M1 on M2. Now can I consider this as action force?
Yes, ma'am.
Now M2 also will apply some force on M1, right?
Yes, ma'am.
Let that be F dash, which is reaction force.
Yes, ma'am.
So what shall we do now? Let me take the free body diagram. I'm taking body M1. So this M1 is exerting some force in forward direction, that is F on M2. Now this M1 is receiving some backward force, that is F dash. Any doubt in this?
No, no doubt, ma'am.
F వచ్చి M1 మీద అప్లై చేసినాము, అదే ఫోర్స్ M1 వచ్చి M2 మీద అప్లై చేసింది, అది ఫార్వర్డ్ డైరెక్షన్ లో ఉంది.
Yes,
అకార్డింగ్
ma'am.
టు న్యూటన్స్ థర్డ్ లా M1 M2 మీద ఫోర్స్ అప్లై చేసినప్పుడు M2 కూడా M1 మీద ఫోర్స్ అప్లై చేస్తుంది.
Ma'am, can you repeat it, ma'am?
M1 is applying force on M2, right?
Yes, ma'am.
Now M2 also applies some force on M1.
Yes, ma'am.
So this F is force applied by M1 on M2.
M2, yes,
F
ma'am.
dash is force applied
By
by
M2
M2
on
on
M1.
M1. So when I want to take the free body diagram only for M1, only M1. So how will be the free body diagram if I take only for M1? In forward direction capital F, in backward direction F dash. అంతే కదా? ఇక్కడ
Yes,
చూడు,
ma'am.
ఇది రియాక్షన్ ఫోర్స్ బై అప్లైడ్ బై M2 ఆన్ M1. ఇది ఫార్వర్డ్ డైరెక్షన్ ఫోర్స్. ఇప్పుడు M1
Ma'am,
మీద
I think places should be, means F. In F dash place, F should come.
in F dash,
In F dash place, F should come.
I didn't get you.
No, ma'am, in F dash place, F should come, ma'am.
In F dash place, F should come. See the direction, Gautam. F direction is forward. The same thing I have kept. F
Okay,
dash
ma'am.
direction is backward. The same direction I have kept. Places చూడొద్దు, direction చూడు.
Okay, ma'am.
So on M1, what is the direction of F forward? No, so I have kept forward.
Okay, ma'am.
F dash direction ekkada backward. So backward.
Okay, ma'am. Here there is no tension force.
Here there is no tension force because there is no spring connected, right?
String, yes, ma'am.
No. So can you tell me which force will be more here? The body is moving in forward direction. That means
Yes.
F is more or F dash is more?
F is ma'am.
F is more. So what will be the net force now? F net
F,
is equals to bigger force F minus
F
smaller force
minus F.
F dash. Now
Yes, ma'am.
according to our principle, F net must be equated to what?
M.
M into A. So I'll equate it into M into A. M is M1 into A. Clear?
Yes, ma'am.
Okay. So this is how you have to write the relations. ఈ రిలేషన్స్ రాయడం మాత్రమే ఇంపార్టెంట్. ఫార్ములాస్ గుర్తుపెట్టుకో, రిలేషన్స్ రాయడం గుర్తుపెట్టుకో.
Yes, ma'am. Ma'am, one doubt, ma'am. Why F naught should be equated to?
Because body is in motion, no? I told you now how to do the numericals. You have to
Yes, ma'am.
construct the free body diagram, take individual bodies, and you have to balance the forces if body is in rest position. But if
Yes.
body is in motion, you have to take F net is equals to m into a.
Yes, ma'am.
ఇక్కడ బాడీ మూవ్ అవుతుంది కదా గౌతమ్, మూవ్ అవుతున్నప్పుడు ఏం చేయాలి, దాని యాక్సిలరేషన్ కి ఈక్వేట్ చేయాలి మనం, m into a కి ఈక్వేట్
Okay.
చేయాలి.
Okay, ma'am.
Okay. So if you use this relation and if you simplify, you will get the value of f dash. Directly you remember, it will be m2 into f by m1 plus
M1
m2.
plus M2.
Okay, so what is this f dash? This is force applied by m2 body on m1 body.
Yes, ma'am.
Any doubt in this?
No, no doubt.
Here?
Clear, ma'am.
Okay, remember these two formulas.
Yes, ma'am.
Now we will take one more case. So what we have done in case A, this is m1 body, this is m2 body. Force was applied on first body. Okay.
Yes, ma'am.
Now, so both bodies will move in which direction? Forward direction. With what
Yes.
acceleration? With a acceleration. What is the formula for this a? It is F
M
applied by
M1.
m1 plus m2. Okay. F1 అన్నా కాబట్టి F1. Now, m2 exerts some force on m1, right? Let it be F dash. So what is the formula for this F dash? You have to take
M2
this
has
mass m2 into acceleration. Acceleration in the F by m1 plus m2.
M2.
Okay. Now same thing, we'll just to take it ulta now. So this is the surface. Let this be body m1. Let this be body m2. This time we are applying force on m2.
Yes, ma'am.
Now body moves in which direction? It moves in backward direction.
Yes, ma'am.
So both the bodies will move with same acceleration, that is A. What is the
A,
formula for A? Same.
yes,
Force
ma'am.
applied by m1 plus m2. Now m1 body also applies some force on m2. Let
Yes,
it
ma'am.
be
That
F dash.
is F dash. Yes,
So
ma'am.
F dash is equals to what now?
M1
This
F, ma'am.
mass m1, exactly. m1 into A. So m1 into what is A value? F by m1 plus
M1 plus M2.
clear?
Yes, ma'am.
Any doubt in this?
No, no doubt, ma'am.
Pakka?
Yes, ma'am.
Okay, now we'll see the third case and fourth case. Third case. So there are three bodies now, m1 body, m2 body, m3 body. Okay, now force is applied on m1 body. Okay, so you try to learn to construct the free body diagram. Okay, so
Yes,
this is
ma'am.
your F. So what is F net? That is equals to m into a, right? Now what is acceleration? F by m. Now here three bodies are there, so what will be the formula for a now? F by m1 plus m2 plus m3. Clear?
Yes, ma'am.
Three bodies are interconnected now. Okay, in the previous case we had only two bodies in contact, so we took force applied by m2 on ma.
Yes,
Okay,
ma'am.
but here we are having three bodies now.
Yes,
So
ma'am.
what I'll do is, here I'll take it as f dash, here I'll take it as f double dash. In your textbook T అనే సింబల్ ఇచ్చినాడు, బెటర్ అది యూజ్ చేయొద్దు, ఎందుకంటే ఆల్రెడీ వి యూస్ టీ సింబల్ ఫర్ టెన్షన్ ఫోర్స్. మళ్ళీ ఇక్కడ కూడా నువ్వు టీ అనే సింబల్ యూజ్ చేస్తే నువ్వు కన్ఫ్యూజ్ అయిపోతావు. మేడం ఇక్కడ
Yes, ma'am.
వైర్ లేదు కదా మరి టెన్షన్ ఫోర్స్ అని కన్ఫ్యూజ్ అవుతావు. జస్ట్ టెక్స్ట్ బుక్ లో జస్ట్ టీ అని ఇచ్చినాడు, బట్ బెటర్ యూ డోంట్ యూస్ టీ. టీ ఈజ్ యూజ్డ్ ఫర్ టెన్షన్ ఫోర్స్. ఇక్కడ ఏ టెన్షన్ ఫోర్స్ లేదు. ఓకే,
Yes,
నా
ma'am.
సో ప్రీవియస్ కేసులో మనం ఏం చేసినాం? సో ఎఫ్ డాష్ ఈజ్ ఈక్వల్స్ టు మనం ఏం చేసినాం? దిస్ మాస్ ఇంటూ యాక్సిలరేషన్, రైట్?
Yes, ma'am.
అదే కదా మనం చేసింది.
Yes, ma'am.
Now this time what we have to do? So this side we have only m2 previous case, but we have two masses now. So what we
Yes,
have to
ma'am.
do now? We have to take the total mass m2 plus m3 into acceleration. అర్థమవుతుందా? కంపేర్ చేసుకో గౌతమ్. ప్రీవియస్ కేసులో ఏం చేసినాం? ఇది ఫస్ట్ బాడీ m1, ఇది సెకండ్ బాడీ m2. దీని మీద ఫోర్స్ అప్లై చేసినారు. ద ఫోర్స్ ఎగ్జర్టెడ్ బై m2 ఆన్ m1 ఈజ్ f డాష్. f డాష్కి ఏం చేసినాం, ఓన్లీ దిస్ మాస్ m2 ఇంటూ యాక్సిలరేషన్. ఇప్పుడు ఇక్కడ ఏమవుతుంది, వన్ మోర్ బాడీ ఈజ్ ఇంటర్ కనెక్టెడ్, సో యూ హ్యావ్ టు టేక్ ద మాస్ ఆఫ్ టూ బాడీస్ నౌ.
Ma'am, but F dash is for M2 and M1 right now, not M3.
Not m3, but they are interconnected, no?
Then M1 should also come, right?
No, because the force is exerted on m1, no?
Yes, ma'am.
Here m2 is exerting force on m1, but m2 is interconnected with m3.
M3, okay,
సో
ma'am.
ఎంతో కొంత ఇప్పుడు m2 డైరెక్ట్ అప్లై చేసినా కూడా ఎంతో కొంత m3 ఇంపాక్ట్ కూడా ఉంటుంది.
Okay,
కాబట్టి
ma'am.
we take the total mass, okay?
Okay, okay.
So f dash will be what now, m2 రైట్ సైడ్ ఏమేం మాస్ ఉందో అది మొత్తం m2 plus m3
Into
యాక్సిలరేషన్ into f by m1 plus
plus
m2 plus m3. Now third case, force exerted by m3 on m2, that is f double dash. ఏం చేయాలి, ఇటు సైడ్ ఉన్న మాస్
M1
తీసుకోవాలి.
plus M2. M1 plus
Force is exerted by whom?
on
m3.
M3. Yes, ma'am.
Force is exerted by m3 body, so you have to take only m3 mass here. Force is exerted by m3 on m1 and m2.
Yes, ma'am.
Who is exerted by, that you have to consider, okay?
Yes, ma'am.
Second case లో it is exerted by m2, but m2 is interconnected with m3 కాబట్టి m2 plus m3 రెండు తీసుకున్నాం. ఇక్కడ ఫోర్స్ ఎగ్జర్టెడ్ బై m3, m3కి ఇంటర్కనెక్ట్ అయి తర్వాత ఎవరు లేరు కాబట్టి ఓన్లీ m3.
Ma'am, but M2 is connected right now for with M3.
Now we are applying force on m2 only, no Gautam?
Oh, okay, okay, ma'am.
ఇక్కడ m1 ఎందుకు తీసుకోలేదు నువ్వు, m1 మీదే ఫోర్స్ అప్లై చేస్తున్నావు కాబట్టి m1 తీసుకోలేదు.
Okay, ma'am.
ఇక్కడ నువ్వు ఏం చేస్తున్నావు, m3 is exerting force on m2 మీద ఫోర్స్ అప్లై చేస్తున్నావు కాబట్టి m2 తీసుకో.
Yes, ma'am.
Okay, so m3 into a. So what is a here, f by m1 plus m2 plus m3. Clear?
Yes, ma'am.
Any doubt?
No, no doubt, ma'am.
We'll discuss it once again.
Okay, ma'am.
లేదంటే నువ్వు ఫ్రీ బాడీ డయాగ్రామ్ గుర్తుపెట్టుకోవాలి. ఓకే, సో ఫస్ట్ కేసులో మనం ఏం చేసినాం, m1 బాడీ m2 బాడీ, ఫోర్స్ ఈజ్ అప్లైడ్ ఆన్ m1, రైట్?
Yes, ma'am.
What is the force applied by m2 on m1? We know it as f dash, right? f
Yes,
dash
ma'am.
ఫార్ములా ఏం చేసినాం మనం, m2 into a అని తీసుకున్నాం. m1 ఎందుకు తీసుకోలేదు ఇక్కడ, బికాస్ ఫోర్స్ ఈజ్ అప్లైడ్ ఆన్ m1, నో?
Yes, ma'am.
ఎవరి మీద అప్లై చేస్తున్నామో వాడిని తీసుకోం మనం. ఈ పాయింట్
ఎవరు అప్లై చేస్తున్నారో వాళ్ళు.
వాళ్ళది తీసుకుంటాం. సెకండ్
Okay.
కేసులో ఏం చేస్తున్నాం అంటే 3 బాడీస్ ని తీసుకుంటున్నాం. ఇది m1 బాడీ, ఇది m2 బాడీ, ఇది m3 బాడీ. ఇక్కడ ఒకటే పాయింట్ ఆఫ్ కాంటాక్ట్ కాబట్టి ఒక f డాష్ వచ్చింది. ఇక్కడ తీసుకుంటే ఏమవుతుంది, ఇక్కడ ఒక పాయింట్ ఆఫ్ కాంటాక్ట్ కాబట్టి ఇక్కడ ఒక డాష్, ఇక్కడ ఒక పాయింట్ ఆఫ్ కాంటాక్ట్ వచ్చింది కాబట్టి ఇక్కడ f డబుల్ డాష్.
Okay, ma'am.
ఇప్పుడు f డాష్ అనేది ఏంటి, ఇట్ ఈస్ ఫోర్స్ అప్లైడ్ బై m2 ఆన్ m1, ఓకే? బట్ కాకపోతే m2 m3 తోటి ఇంటర్ కనెక్ట్ అయిపోయింది కాబట్టి m2 తో పాటు m3 కూడా తీసుకుంటాం ఇంటూ a.
Okay, ma'am.
ఓకే, ఇప్పుడు నెక్స్ట్ f డబల్ డాష్ అంటే ఏంటి, ఇట్ ఈస్ ఫోర్స్ అప్లైడ్ బై m3 ఆన్ m2. ఇప్పుడు m3 తర్వాత ఎవరైనా అఫ్ కోర్స్ లెఫ్ట్ సైడ్ ఇంటర్ కనెక్ట్ అయి ఉంది విత్ m2, బట్ ఫోర్స్ ఈజ్ అప్లైడ్ ఆన్ m2 ఇట్ సెల్ఫ్, సో వి డోంట్ టేక్ ఇట్. సో
Yes,
రైట్ సైడ్
ma'am.
m3కి ఇంటర్ కనెక్టెడ్ ఎవరు లేరు కాబట్టి m3 ఇంటూ a.
If one more body M3 M4 is there, then M3 into M4.
అప్పుడు ఏం చేయాలి, ఇక్కడ m2 ప్లస్ m3 ప్లస్ m4 అని వస్తుంది. f డబుల్ డాష్ లో m3 ప్లస్ m4 వస్తుంది. f ట్రిపుల్ డాష్ లో ఓన్లీ m4 వస్తుంది.
M4. Okay, ma'am. Now I understand, ma'am.
క్లియర్?
Yes, ma'am.
And how do we derive, ఇది షార్ట్ ట్రిక్ అంతే, బట్ how do we get all these relations with the help of free body diagram?
Okay, ma'am.
Okay, all these formulas are derived with the help of free body diagram, but మనం ఈజీగా గుర్తుపెట్టుకోవడానికి నేను నీకు చెప్తున్నాను. నెక్స్ట్,
Okay.
so let us take one more case. So let this be body diagram m1 M2 and M3. Okay, so this time force is applied in backward direction. So body will move in which direction? It
Yes,
moves in
the
backward
backward.
direction with acceleration A. So what is formula of A? A is nothing but F by M. Three masses are interconnected. So F by M1
M1 plus
plus
M2
M2
plus
plus
M1.
M3. This is first formula. Any doubt in this?
No, no, ma'am.
Now, so F is applied on M3. So this M3 applies force on M2. M2 force applies on M1. ఇదంతా backward direction లో. ఇప్పుడు
Yes,
forward direction. M2 applies force on M3. Let it be F dash. M1 applies force on M2. Let it be F double dash.
yes,
Okay.
ma'am.
So if F dash కి ఏమవుతుంది? F dash కి backward direction లో two bodies interconnected కాబట్టి M1 plus M2 into A. A is nothing but F by M1 plus M2 plus M3.
Um, okay, ma'am.
Any doubt in this?
No, no,
Now
one man. Yes,
now F double dash. F double dash అంటే ఏంటి? It is force applied by M1. So M1 side opposite లో ఏమీ
only
ఏం
one,
లేదు.
ma'am. Only
కాబట్టి
M.
M1 into A.
Plus
A is nothing but F by M1 plus
plus
M2 plus
M2 plus
M3.
M3.
This is third formula. అంటే కాన్సెప్ట్ సేమ్. నీకు అర్థం చేయించడానికి టెక్స్ట్ బుక్ లో టూ బాడీస్ ఇన్ కాంటాక్ట్, త్రీ బాడీస్ ఇన్ కాంటాక్ట్, డిఫరెంట్ కేసెస్ ఆర్ గివెన్, బట్ ఆల్ మీన్ ద సేమ్.
Yes, ma'am.
ఓకే.
Ma'am, in M1, ma'am, the force is exerted on M2 by M2 on M3.
Yeah, directly applied on M2, but a little effect is also there on M3.
M1. Okay.
Okay.
Okay, ma'am. Now I'm.
Okay. So we'll just do a small problem and then I'll wind up the class. Okay. So see your textbook, a question is given. So a force of 12 newtons acts on block A and block B of mass 2 kg and 4 kg respectively as shown. Okay. So there
Yes,
are
ma'am.
two blocks. One is 2 kg, one is 4 kg. అంటే మాస్ డిఫరెంట్ కాబట్టి ఒకటి చిన్నగా ఒకటి పెద్దగా తీసుకో. సో ఫోర్స్ 12 న్యూటన్స్ యాక్ట్స్ ఆన్ బ్లాక్ ఏ. బ్లాక్ ఏ మాస్ is how much? 2 kg. Block B mass is 4 kg. A మీద force apply చేసినాం. So let this be A, let this be B. Force is applied here of 12 newtons. This is 2 kg body, this is 4 kg body. Okay. Given that the floor is smooth, that means there is no need to consider friction. What is acceleration of block A? See, acceleration of block A, acceleration of block B all mean the same because both are interconnected directly.
Yes, ma'am.
Okay, so acceleration will be in backward direction. What is the formula? A is equals to F by M. So A is equals to what is force? 12 newtons. What is M here? Two bodies are in contact. So you have to take both the masses. 4 plus 2.
6,
So
12
12
answer.
by 6, it is 2. What is the unit of acceleration? Meter per second square.
Yes, ma'am.
Meter per second square ఎందుకు తీసుకున్నావు? Because force is in SI system, mass is also in SI system.
Yes, ma'am.
Meter per second square SI unit. Clear?
Yes, ma'am.
I thought of completing, but it takes more time, I think. Tomorrow I'll tell you about tension case, that means string force and Atwood mission, and also we will do some numericals. Okay.
Okay, ma'am.
ఫ్రిక్షన్ అవసరం లేదు కదా, మళ్ళీ చెప్పాలా?
వద్దు వద్దు మ్యామ్.
Okay, so you just go on revising. Tomorrow we will do the remaining part and problems. Okay.
ఓకే.
Tomorrow, Gautam, I will not take the class tomorrow. I won't be available. Okay.
ఓకే మ్యామ్.
So I'll take the class on Friday.
ఫ్రైడే.
Next class is on Friday. Okay.
ఫ్రైడే ఓకే మ్యామ్.
Okay. So today I took 15 minutes of time extra. So the next class is only for 45 minutes.
ఓకే మ్యామ్.
Okay. Today I took 1 hour 15 minutes class. So next class I'll take only 45 minutes time. And next class, if tomorrow possible, I'll take Gautam. If not, on Friday.
ఓకే మ్యామ్. మ్యామ్ యూ జస్ట్ ఇన్ఫార్మ్. యూ జస్ట్ మెసేజ్.
Yeah. If I take to 99%, I'll not take class tomorrow. If I take, I'll inform. Okay.
ఓకే మ్యామ్.
Bye, Beta.
బాయ్ మ్యామ్. థ్యాంక్ యూ.